All right, in this lesson, we're going to be working on doing some mixed quadrilateral practice, and all of these are going to be numerical examples. So typically, with all the lessons that we've done thus far, they were specific to the shape. So obviously, if we're in a rectangle unit or a rectangle lesson, we know that we're going to be using all the properties of a rectangle. But in this lesson, we're going to be working with all of the shapes that we have. So it might be a little bit tougher to figure out which properties we need to use. So a general approach for all of these questions is you guys have to make use of your annotating skills. So you should be annotating what the question says along with the givens, and we should specifically circle, highlight, or underline the specific shape that we are working with if they give us one. Once we know the shape we're working with, what I like to do is I'll list or think about or even label on my diagram the unique properties of it right off the bat, just so that I kind of have a general idea of things, and it might help to get a visual example of what we're supposed to solve for. And with that being said too, with number 1, I should have added, if there's no diagram in there, you should draw one. Number 3 says identify what the question is asking you and figure out the actual property or properties that you need to apply. So you're going to be making an equation based on a property. That's really how all these questions are going to go. Then you always want to label the values that you find on your original diagram, because these questions might be multi-step. So you always want to kind of take a step back after you solve for something, think about what it actually represents in your shape, and don't box your answer until you're sure that that's what the question wants. So let's just get into a couple of examples. We're going to do 3 today. So it says in rhombus ABCD, AB is 8 and AC is 15, and it wants BD to the nearest tenth. So I am circling rhombus, and I'm also going to circle or box nearest tenth, because sometimes we rush so much that we don't pay attention to what the question wants us to round to, which could be very, very bad for us. We can lose a point just for that. So I'm going to go ahead and just draw a shape. And I know that this is a rhombus. So when I'm labeling, I'm making sure that I'm being consistent and I'm not skipping any side. So A, B, C has to go here, and D. And we have that AB is 8, and we have the AC, which is the diagonal, is 15. And it wants us to find the value of BD. So I'm going to go ahead and draw the other diagonal in there as well. Now what we know about rhombi, the unique properties, I'm going to list them for now, is that our diagonals are perpendicular. So I'm going to actually go ahead and draw my right angles in there. I know that, and this is from memory, I know all sides are congruent, so bear with me if it takes me a second. And then the last one is that diagonals bisect the angles of the shape. So see, if I didn't know my properties of a rhombus, I'm not going to be able to solve for this at all. Now I'm going to make a change to what I just did. So it said that AC is 15. That's the entire value of the diagonal. So what I'm going to do to kind of clear my picture up a bit, I know that from a parallelogram, right, because a rhombus is a type of parallelogram. So way back when, we know that in all of these parallelograms that we're working with, the diagonals are bisecting each other. So right now, at the intersection point of my diagonals, they're being split into 2 congruent pieces. So I know that this is going to be 7.5, and that's going to be 7.5. But be careful, because in a rhombus, we don't know that the diagonals are congruent, so we need to make sure we're differentiating here with our number of tick marks. All right, so I'm going to go ahead and erase that 15 that I wrote in there, just to clear up our picture a little bit. All right, now what does it want? It wants the length of BD, so it wants the length of the entire other diagonal. And this is going to be a multi-step one. So first, I'm going to call the intersection point here, let's just call that E. First thing I'm going to do is find BE. And I'm going to be able to do that by taking one of these right triangles, and I also skipped something actually. Let's do this in like a light blue color. In a rhombus, I know that all sides are congruent, right? So I know that if AB is 8, I know all of the other sides are going to be 8 as well. Now to find BE, I'm going to just take a right triangle. I'll take this right triangle right here, which is going to be BEC, and I'm going to carry over what I have. So I have 7.5, and I have 8, and I don't know this value here. And I do have that right angle in there. So we're going to use a squared, we're going to use Pythagorean theorem. A squared plus b squared equals c squared. And again, I really know this by like labeling my picture, right? If I didn't have these right angles labeled in here, it might not stand out to me that I have right triangles, and then I might not be able to figure out that I can use Pythagorean theorem. So x squared plus 7.5 squared equals 8 squared. We want to make sure that this value is always the hypotenuse. And I have a calculator handy on the other screen. So we have 8 squared is not obviously, but I can do it in my head, 64. And then on this side, let's do 7.5 squared. And we get 56.25. So we have x squared plus 56.25 equals 64. We can go ahead and subtract this on both sides. And we're going to get x squared equals 64 minus that 56.25, and that's going to be 7.75. Now we got to take the square root, so we get x, we take square root of both sides, so we want the square root of 7.75, and that's going to give us 2.784. So I round to, I usually do 3 decimal places to be safe, and then I go to the question, and it wants the nearest tenth. Well, actually, we're not even done. See, I just made a mistake that you guys probably would have made. So now we got to go and think about what this actually represents. So this actually represents BE, right? BE is equal to 2.784. Now, that's not the length of the whole diagonal, right? Because what it wants is, it wants BD, the length of the whole diagonal. So we have to use that property that I know this side's also going to be the same. So when we add these two together, and in my calculator, I'm not putting 2.784. I'm actually using that whole decimal, and I'm just going to add it to itself or multiply by 2, and then I'll round at the very end. So now, the second thing is to find BD. And when we multiply this value, when we take the square root of 7.75 and multiply it by 2, that gives us 5.568. And then we need to round that to the nearest tenth, which is going to be 5.6. So BD equals 5.6, and we box that answer. See, I almost got tricked in that one. So it's very easy to get tricked. Now, second example in rectangle ABCD. So I'm going to go ahead and draw that. Rectangle ABCD. Before I even read, I'm going to put my corners A, B, C, D. I'm going to draw my diagonals in. I'm putting my right angles in. What else do we know about a rectangle? We know 2 things. We know all angles are 90, which we labeled, and we know that the diagonals are congruent. So I can go ahead and label each smaller piece as being congruent as well. So let's label now. We have AC, which I'll use colors because our picture can get messy. AC, that whole thing is 3x plus 15, and then BD, which is this whole thing, is 4x minus 5, and it wants the length of AC. So I know first we need to solve for x, and in order to solve for x, they give us the value of both diagonals, and we know those diagonals are congruent, right? So we can say 3x plus 15, which is the value of AC, is going to be equal to 4x minus 5, which is the value of BD. And then we can do some algebra here. If we add 5 on both sides, we'll get 3x plus 20 equals 4x. And then we can subtract 3x, and we get 20 equals x. But do not circle your answer here. We want the length of AC, right? So to find AC, AC is equal to 3x plus 15. And we got to substitute that value in. 3 times 20 plus 15. So that's going to give us that AC equals 75. Okay. And very last but not least, we have an example with the square, the perimeter of a square. And before I even read, I'm drawing my square, and I'm going to try to label what I know. Now remember, square was the combination of rectangle and rhombus. So 1, I know all angles are 90. I know diagonals are congruent. This comes from the rectangle portion of it. And then I also know diagonals are perpendicular. I know all sides are equal or congruent. And I know diagonals, I'll just write are angle bisectors, right? Which means they bisect the angles of the shape. And again, this comes from the rhombus portion of it. So let's go ahead and label. The perimeter of a square is 56. It doesn't really tell us what the letters are, which is fine. But I know we have right angles, right angles, right angles, right angles. If I draw my diagonals in, I know they're perpendicular. I know all 4 of these pieces are congruent, and even stronger, I know all 4 of those angles are 90 degrees as well, or 45 degrees as well. And I'm going to go ahead and label all of my sides as being x as well. Now it tells us the perimeter is 56, and we know that the perimeter is all 4 sides added together, so that can actually help me find a side length. If we do 56 divided by those 4 sides, that's going to give us that a side length, or x in this case, is 14. So I'm going to go ahead and label that. Okay, now what does it want? It wants the length of a diagonal in simplest radical form. So I'm going to go ahead and redraw my square. I got a lot going on in the other picture. I'm going to redraw my square, and I'm going to use the shortcut that we did in class together. So we have 14, 14, 14, and 14, and it wants the length of a diagonal. So the shortcut is that your diagonal of a square, and if you want to star this, your diagonal is always going to be in the form of blank radical 2. Always. Now, if you have a side length, and you know your side length is 14, your diagonal is going to be 14 radical 2. So it's usually your diagonal is your side length, and this is just for a square. So diagonal of square is just a side length radical 2, always. But you could also use Pythagorean theorem with this right triangle right here. And if you did do Pythagorean theorem, it would be 14 squared plus 14 squared equals x squared. And when you actually solve that, you will get 14 radical 2. All right, so this is just going to take some practice. It really involves you knowing the properties. If we don't know the properties by heart, it's going to be really hard to do these questions because you're not going to have any type of reference sheet on the exam with you. So make sure we are reinforcing those properties of our flip book and our quadrilaterals so that doing these problems are just easier for you.